Okay, here's another problem where you need to find the area of the region enclosed by the curves. So you first decide which one is the upper function. It's the positive x squared function. So this is the function above. This is the function below. So the way that you set it up, and it's the area between the curves, right? So remember, between something is the difference. So we're going to say the area is the integral, and it tells us the lower and upper bound, -6, -1. I don't think we did this one. So it's bigger set of parentheses because it's going to be this set, subtract this set, dx, and I'll make my pen a little bit smaller so that I can fit it all in. Okay, so x squared over 2 plus 4x plus 10, subtract, well that's negative x squared over 2, subtract 2x, subtract 1. Well, we're going to simplify this a little bit. So a is equal from -6 to -1. It's a little bit too, all right. There we go, that's a little bit better. Dx. Well, x squared over 2, subtract a negative x squared over 2. Well, that's like adding a positive, and 1/2 plus 1/2 is 1 whole. So we have x squared. 4x, subtract a negative 2x, is adding 2x. So 4x plus 2x is 6x. And then 10, subtract a negative plus 1 is 11. All right. So now we are ready to integrate. There's 3 pieces. Now we could use the integration laws and add. Remember, the integral of the sum is the sum of the integral. So we could write this integral, put the x squared in there, plus this integral, put this in there, plus this integral, put that in there. However, that doesn't, you don't necessarily need to do that, but if you ever have one that says using integration laws, that's what it means to do. Okay, I'm just going to go ahead and integrate this. So the integral of x squared, so let's see, we're going to add 1. So 2 plus 1 is 3, so it's going to be x cubed over 3. And then 6x, we're going to the first, we're going to add 1, divide 2. Well, 6 divided 2 is 3, so plus 3x squared. And then remember, if it's a constant, we just tack on an x, because x to the 0 plus 1 divide 1, it doesn't change anything. And then we're going from -6 to -1. And that's where you do f of b subtract f of a. So uppercase f of b subtract f of a. So when we plug -6 into there, -6 cubed is -216, divide 3, and it looks like that will go in evenly, so we'll do that in a second. -6 squared is 36. 36 times 3, I believe, is 108. And then -6 times 11 is -66. We're going to take those, and now we're going to subtract. Oh man, me and my reversing. That's the f of a. So the f of b will subtract all of that stuff. All right. This is the b, this is the a. All right. So when we put -1 in there, -1 cubed is -1, so that's -1/3, plus -1 squared is 1, 3 times 1 is 3, -1 times 11 is -11. All right. Well, negative 1/3, subtract a negative 216 thirds. So that's adding 216. So 216 subtract 1 is 215 thirds. Now this doesn't go in evenly, so I'm glad I didn't change that right there. 3 subtract 108 is negative 105. And then negative 11, subtract the negatives, adding to positive. So that's positive 55. All right. So negative 105 plus 55 should be negative, let's see, so 215 thirds. Subtract 50, it looks like. Yeah, so subtract 50. And then go ahead and do the math. If I want to turn this into the same denominator, I'll multiply top and bottom by 3. That will be 150 thirds. So 215 subtract 150 is 65 thirds. 65 thirds units squared. And then you could also do the decimal value, which sometimes is helpful. There you have it. Just don't reverse like I did initially, the A and the B. This is f of B, and B is always your upper bound, and this is f of A. All right, that's it for this one.